Got the motor wired up, everything together. Plugged into my other old Z-axis just for testing. See the belt and the tensioner in there and the ground strap in there. It's got tension on it through that spring. Doing a dry run test, pushing the speeds and fine-tuning the rotary axis. Cutting out some gussets like this, except for the torch is disabled. It keeps 1/16 of an inch of clearance. And there it's done. And would have made 6 of these gussets. Parts here. We'll hit go. Parts fell off. Here's our scrap. And here's our gussets. And they look a little bit dirty because all the junk gets inside the tube, but tossing them in the rotary tumbler or just a quick tap on the wire wheel, and then I usually just run the faces of them on the sander just to clean up the faces. But then it gets you some real nice accurate parts out of square tube or round or rectangular, whatever you're cutting. go. That's what it ends up being. I got a little dirty because it gets dirty on the inside of the tube with the plasma cutter. But we'll just stick that in the tumbler to clean it off. And when you get done, we added a little logo on this one just for the heck of it. But then it ends up being a little chair. Okay, I promised this video to Les as he helped me fine-tune some things in my post-processor for Sheetcam, which is a wonderful program. We got these little gussets right here, and they're pretty simple, but they're kind of a pain to cut out. And these are for these four-wheeler swing arms. We'll cut them out in different sizes and weld them to the swing arms. And so to cut these out of 1.5 inch square tube, I'll take you through the steps a little bit. Here in the drawing, we need to draw it up. We can't just draw 1.5 inch by 1.5 inch by 1.5 inch because we have the radius corners and that distance is smaller. And the drawing on here, let's go to Sheetcam real quick. This is what it pulls up in Sheetcam. Your little guidelines. This is your the center of the corner, and these are the edges of your radius, and then of course your 4 flats per side. That is all set up in options under Rotary Plasma. You set up your beam width, beam height, the corner radius, and the wall thickness, and then that gives you this. Well, in order to draw that up correctly, we need to figure some things out. The 1.5 inch tubing has a 7/32 radius, which is basically the measurement from where it starts right here to the edge of the tube. That's your radius distance. And so then to compute the flat side distance on the tube, we need to take 1.5 inch, which is the tube size, minus the radius times 2, which is 7/16 of an inch. So we get 1.0625, or 1 1/16 for our flat distance. Now for the radius distances here, to figure out the circumference of them, basically take your radius times 2, which will give you the diameter, and times that by pi, which is 3.14159, or I usually just use 3.142, and then divide that by 4, and that equals your radius, the distance, the linear distance around your radius in the corner. Sounds complicated, but it's not actually that hard. So then you need to draw your radius distance from here to here, flat distance from there to there, and then I like putting a line in the middle of the radius for the edge of the tube, and that's how you can get what you want. Now these gussets, they were pretty simple. I basically drew them how I wanted them. I drew this leg, and connected the two, and I drew it flat, and then rotated it up here, and then drew my lines connecting, and that gives us a plenty respectable gusset. I mean, with no ortho correction for the sides or anything, or 3D CAD or anything. So there, that part's done. Oops, wrong Sheetcam. Now we got Sheetcam, and here's what we're laying out. We're cutting out 6 of them and then cutting off the tube. I have selected my tool like normal, and you can go up here to simulation to see a simulation of it. Let me rotate this a little bit. bear with me. Okay, now here's the simulation. It just shows you what's happening. We'll override the feed rate a little bit on this one. But anyways, enough of that. Let's cut some parts. So now I've loaded my part into Sheetcam. This is what it's looking like. And I was fine-tuning the rotary axis, and just some quick notes on that. For my setup, when you set up the steps in the Sheetcam post, here, I'll pull that up real quick. Machine. Okay, when you set up your variables in Sheetcam, I'm using the Plasma Rotary Mach 3 swapped axes post, except for it is slightly or highly modified. The important part is, I have a Scribe on this, but won't be using that in this video. Here's your units per rev. That is 1. That means it thinks that 1 inch per 1 revolution, and that is just completely fine for what we're doing, because Sheetcam does all the calculations. But in order to tune your motors correctly, I have figured out your tube size, say 1 inch through 6 inch size tube or rectangular section. The circumference of the tube, these are the circumferences of the tube, which is calculated by timesing it by 3.142. And then the accuracy can be figured out by taking your steps per inch, which mine is 1440 steps, and that is calculated by the gear ratio of my rotary drive, which is 7.2 to 1, and we have 200 steps originally, and times 10 for microstepping, so that's 2,000 steps per rotation times the 7.2 gear ratio equals 14,400, which is right there. Now to figure out the accuracy, okay, to continue the last video, we were talking about verifying the accuracy that I have. I figured this out before I built the rotary chuck. That's where I arrived at the 7.2 gear ratio with my motor and setup, but having 14,400 steps per revolution, 1 revolution of 1 inch pipe equals 3.142, so we take 3.142 and we divide that by 14,400 steps, and we have a step size, a microstep size of 0.0002. That is plenty sufficient for accuracy. And if we go up to 6 inch pipe, we still have 1/1000th accuracy with microstepping. Without, it's 10,000ths, but the microstepping brings it down to 1/1000th accuracy. And now for the speed, you can see the speeds. I'm going to go with 50 inches per minute, or units. It would be 50 revolutions per minute as set up with the Sheetcam, and the Mach being 1 revolution is 1 unit. So at 100 RPMs, the inches per minute that we're capable of achieving on 1 inch pipe is 314 inches per minute. It's set up at 50, 157 inches per minute is the fastest we can do. Now, I don't typically do 1 inch pipe, but 157 is more than sufficient for that. And we step up to 2 inch and it's 314 inches per minute on the effective circumference or outer diameter of the pipe or tube, and that is plenty. Okay, now back to what we were doing. After all those notes, we got it set up in Sheetcam. Our drawing, here it is drawn. And I just make this something that is like a template for the different tube size that can't be changed, and I just draw over top of it, make them on different layers so that only the cutting layer shows up in Sheetcam. Go to Mach 3, and that's what it looks like. It looks all goofy, but here's the rotary axis on the table set at the back, and here I've got a little guide rail underneath that was set to be on the same axis and level with the table, and then the rotary chuck in line with it. And then I've got these little clamps. Just loosen the clamp, slide it forward or backwards, or you can pull it off if you're not using it or you need to change sides or put a different one on. Then for square tubing, I have gone and just made this round support which captures 3 points of the tube at all time, so it keeps it rotationally in the same direction, but I can still cut on the top, and it works pretty slick. For round tubing, we'll just have a couple rollers under the bottom. But anyways, parts here. We're going to cut some parts. We'll hit go. Parts fell off. Here's our scrap. And here's our gussets. And they look a little bit dirty because all the junk gets inside the tube, but tossing them in the rotary tumbler or just a quick tap on the wire wheel, and then I usually just run the faces of them on the sander just to clean up the faces. But then it gets you some real nice accurate parts out of square tube or round or rectangular, whatever you're cutting.